The first example we're going to discuss has to do with measuring the anti-wear performance of hydraulic fluids. Now, hydraulic fluids are used in a lot of heavy equipment for power transmission. Fluids need to be pressurized by a pump, and a certain measure of anti-wear property of the hydraulic fluid is necessary to protect the pump. Now, the challenge is that there exists a component test for evaluating this, but this component test is quite expensive and time-consuming, and it provides little information on friction. So the starting point is that we have the Conestoga-Vickers Vane Pump test, a component test that is standardized, but that requires a lot of oil to be used, 5 gallons, or for the ISO test even more, and a long test duration. At the end of the test, we only measure wear loss. So our challenge is to look for a simulation of this test and accelerate the testing without actually changing the wear mechanism. And the way we do this is by using a set of dedicated test specimens that you can see in the right bottom corner here. These test specimens can be fitted in the Falex multi-specimen machine, and they are designed to recreate the contact conditions, a sliding line contact of a vane pump. These are then set up in the test machine. And of course, an oil reservoir is placed around this, and we use a recirculation of the oil to lubricate the contact. After a test, we have to evaluate the wear mechanism that has occurred on these vanes, and we have to verify that it's the same wear mechanism that is also happening in the component or in the vane pump test. And as we can compare these two scanning images, we can see that with the test method we have on the Vickers vane pump test or the test method we have on the multi-specimen test, we get similar wear mechanisms. The advantage of the screening test, of course, is that the duration is a lot shorter than on a vane pump test. We also need to use a lot less oil, and one test is also less costly in specimen costs. So we have a real advantage in testing faster and more efficiently. Of course, the test results have to correlate with reality. And this is something we have checked in an extensive comparative program. We have used 5 different hydraulic fluids and ran the Conestoga tests on them in-house. We also ran the multi-specimen simulation test on it. And we can find that the Vickers test and the multi-specimen test result in the same ranking of the fluids. The absolute values of the results don't match up precisely because, of course, we are doing a simulation. We have simplified the mechanism a little bit, and it would be too great to expect to have a perfect correlation. But we can rank the fluids very well, and we can therefore evaluate the effects of composition or test parameters on the fluid without having to go and run the complete component test. An interesting thing is also that we have discovered that our simulation test is quite sensitive to concentration of additives. So comparing 3 hydraulic fluids with 3 concentrations of additives added to it, 0 to up to 0.6%, which are quite small percentages, we can see that the weight loss in the simulation test is quite sensitive to these concentrations. In addition, we can measure the friction, and it's important to note that friction doesn't necessarily have to correlate with the wear, but it is interesting to see that different fluids generate a different friction response or have a different energy loss in the contact. And this can also be relevant for the energy consumption of the system.